All right, welcome to day 7. So your only homework for tonight is to make sure you have memorized the 4 formulas you have on the front of your packet. And I have them right here in case you don't have them and need to write them down for any reason. So those are the 4 you need to study tonight. You need to make sure that you could, on the test, write them right on the top of the test so that you have them almost like it's like a second formula sheet. So you have your arithmetic series formula, Sn is equal to n over 2 times a1 plus an. You got your geometric series formula, a1 over 1 minus r, and there are ways to find d and r if it's not obvious. So our warm-up we can be putting on the Tuesday box. So we always want to ask first arithmetic or geometric. Well, if you go from 6 to negative 12, you're going to be subtracting. If you're at negative 12 and subtract again, that's not going to get you to 24. So this must be geometric. So we know we're dealing with geometric series, and it's not infinity, so that means we're doing the one on our reference sheet. The Sn is equal to a1 minus a1 times r to the n over 1 minus r. So we're going to have S14, our a1 is 6 minus 6 times our r, we'll figure that out in a second, over 14 over 1 minus whatever our r is. So we have right here next to us, our r formula is a2 divided by a1. So we're going to have negative 12 over 6, which is just negative 2. So this is why it's important to put r in parentheses. We want that negative 2 in parentheses raised to the 14th. And it's minus a negative 2. So you could switch it to a plus if you wanted, or put it in as minus a minus. When we put that all in the calculator, we end up getting that the sum of the first 14 terms is negative 32,766. So here's each of the homework ones. Again, I'll just pause on the screen for a second. You can pause the video to check your answers. Ones you have questions on, you can post on the discussion board. The content discussion board, I should specify. Alrighty, so today is going to be a practice day where we're going to kind of pull everything together that we have done. So we want to generate the next 3 terms of the arithmetic sequence. Well, notice we've got an a sub n minus 1 there. This is a recursive formula. So they already tell us that a1 is 3 halves. So to find a2, we're going to be using this setup here. Remember, a n minus 1 just means the previous term. So we're going to start with the 3 halves that was our previous term, plus a half. So that's going to give us 4 halves, which is the same as 2. So that's our next term. We got to do 3 more. So a3, again, this is saying do the previous term and then add a half. So our previous term now is 2. So we'll add a half. And we can either do 5 halves or 2.5. And a4, just do your previous term and add a half, so we would get 3. So our answer to this question would be those 3 next terms, the 2, the 2.5, and the 3. So we're going to skip exercise 2. So what we're going to do here is we're going to find the value of a20 given a1 and a4. Well, if it's an arithmetic sequence, we know eventually we're going to use this at some point in the problem, right from our reference sheet, our arithmetic sequence formula. We want to find a20. Well, we know a1 is 6, n would be 20, but the problem is we don't know d. So what we can do, so here's our a1, here's our a4. We can use that arithmetic sequence formula off to the side. We can take the value of the last term, 18. Our first term is 6. N would be 4, because 18 is the fourth term. And then we can use that to solve for D. If we subtract the 6 over, we'll get 12 equals 3D if we neaten up the right side. Divide by 3, and we get D is equal to 4. So now we can just plug that 4 in over here, and that'll allow us to find the 20th term, which if we put that in the calculator, just gives us 82. That seems reasonable because if we're going from 6 to 18, it should be getting larger each time. All right, going to the top of page 34, we're given an arithmetic recursive formula, and they tell us what T1 is. Well, the thing we want to get from this recursive formula is that our D is 7. We're adding on 7 over and over again. They're just telling us saying T instead of A, but like our A1 is -5. So we want to find T4 and T20, which that's the same as saying A. So if we want to be consistent with the question, instead of writing AN, we could write TN is equal to T1 plus N minus 1 times D. And that's just our thing from the reference sheet, but they're using T's instead of A's. So we want to find T4. Our T1 was -5, plus our N is 4, because we're finding T4. And our D we identified was 7. And if we punch that all in, we get 16. And then for T20, all that's going to change is our N value. And when we punch that all in, we get 128. We're going to skip the bottom of page 34, and we're going to go to the top of page 35. So this is going to be pretty similar to what we did 2 questions ago. So we want to find A12, and they told us it's an arithmetic sequence. So we know from our reference sheet, we should use our arithmetic sequence formula to find A12. So A12 is going to equal the first term that they told us, plus 12 minus 1, because we're dealing with the 12th term, times D. But the problem is we don't know D. Well, we know we have -4, comma, blank, second term, third term, fourth term, fifth term, and our sixth term is 46. So we can use that fact to do a little formula off to the side. Our AN would be 46. -1 is our fourth term. We'd have 6 minus 1, because N would be, or 6 would be our spot number, N. And then D, and we can use that to find D. If we add the 4 over, we get 50, and this would neaten up to 5D. Dividing the 5 over, we just get that D is equal to 10. And then we could now punch this in the calculator to find A12, which would just be 106. Moving down to the bottom of page 35, they tell us arithmetic sequence, so we know we should be using our arithmetic sequence formula right off of our reference sheet. And we want to find the first term, meaning we should know everything else. The common difference is 7, they tell us that. The 22nd term, so that's our N. We don't know A1, and the value of that 22nd term is 143. Well, now we just need to solve for A1. If we do out that part, we get 147. And if we subtract that from both sides, we get negative 4 is our A1. And moving to the top of page 36, we've got another recursive formula. And they want to find the next three terms. So it's kind of like the first example we did, but with geometric now because we're multiplying. We know A1 is 16. Remember, AN minus 1 means just do the previous term. So we're going to do 16 times 3 halves. Well, when you multiply by 3 halves, that means we should multiply by 3 and divide by 2. You can do those in either order. 16 divided by 2 is 8. 8 times 3 is just 24. And if you're not sure of that, you can just put it in the calculator. We'll do previous term times 3 halves again. Well, multiplying by 3 halves means divide it by 2 and multiply it by 3. 24 divided by 2 is 12. 12 times 3 is 36. And similar idea for the last one. Previous term is 36. Times the 3 halves would give us 54. So our answer would be those three values, because those are the three next terms. All right, if we're geometric, it means we're multiplying over and over again. If we go from 5 to 15, when we go from A1 to A2, that means our R is just 3, because we're multiplying each time. So A3 would just be multiplying by 3 again, and we get 45. Well, to find A10, we would want to use our geometric sequence formula from our reference sheet. Remember, to get in the habit of putting that R in parentheses, we want to do A10. Our first term we knew was 5. R we said was 3. And we're doing 10 minus 1. And when we punch that in, we get 98,415. And I guess we could just show here that we did 15 times 3 to get the 45, because it specifically says to show our calculations. All right, then our last one for this video, geometric sequence. So we know from our reference sheet we should be using A1 times R to the n minus 1. We eventually want to find the value of A10. So we'll have A10 is equal to our first term, negative 1, times R, which we don't know yet, and then we'll have 10 minus 1. So we've got to figure out R, and we're going to use this information to find it out. Negative 1 is our first spot. We don't know A2, we don't know A3, but we know A4 is 64. So we can do a little geometric sequence formula off to the side. Our value of the last term is 64. A1 is negative 1. We don't know R, but it's raised to the 4 minus 1 for the n minus 1. Divide the negative 1 over, and we get negative 64 equals R to the third. The opposite of raising something to the third is doing the third root, also known as the cubed root. Cubed roots, you don't put a plus or minus out front, only any even root. With any odd root, it's just the sign of whatever's underneath. So we're going to have minus, and the cubed root of negative 64 would just give us a 4. So that's our value of R. We'll bring it over here, and then we just punch everything in, making sure to be careful that your R is in parentheses, and we get 262,144. So there's nothing you have to turn in for your homework for tonight, but it is on you to make sure when you come to class next, you have those 4 formulas memorized.